So if you have to explain to someone what a container is, you can simply say that containers are a virtualization technology. Full stop. Now, what's the objective? The idea here is to isolate a main application and all of its dependencies inside these portable software units. Now, these software units, they are designed to be lightweight and they follow a specific standard such that we can guarantee that they will behave the same regardless of the environment where they run. So containers as a concept, it's an old thing. It has been around for decades. In their modern form, though, as we know them today, they became more popular around 15 to 17 years ago, first with LXC system containers and then with Docker application containers. So the next logical question is, okay, it's a virtualization technology. How does it compare with a virtual machine? This is a fair comparison. VMs, they aim to virtualize an entire computer, all the way from hardware to a guest operating system where your application will run. And they will do this through an hypervisor, which can either run directly on bare metal or on top of a host OS. Now, in contrast, containers will not virtualize the entire thing. They will rely on your physical machine's kernel to share the resources that already exist there, those physical resources. And this will make them much faster to start, much smaller than an entire VM. There's no need to virtualize the entire OS to get the container running. Why should you use containers, right? VMs, containers, both are virtualization technologies. You may have different use cases. You need to understand what are the benefits, how those apply to you. So let's start with the fact that containers are designed to be portable and consistent. Because you are packaging the application and dependencies in this portable software unit, there is this kind of guarantee that when it is executed as a container, it should run, it should give you the same behavior on your computer as it will on someone else's computer. So regardless of the working environment, the behavior should always be the same. There's no longer this idea of, oh, it works on my machine, but not there. So there's consistency. And the whole thing, the software unit is meant to be portable because it follows a specific standard. They are lightweight, as we just said during our comparison with VMs, because there's no need to virtualize the entire computer. You are just relying on C groups and namespaces to achieve resource sharing and isolation. You will achieve a similar isolation to a VM, not as strong, but still, and you will just share the resources that are available from your physical host. So the thing will start in seconds instead of minutes, which would be what you would expect from something that needs to virtualize the entire OS, the entire computer. Now, very similar to the previous, there's resource efficiency because you don't need to virtualize the whole thing and waste resources on trying to bootstrap an entire computer. Just run a very simple application that may not need the entire amount of resources you are virtualizing, which is the case for VMs. Here, you are just maximizing the amount of resources you are allocating for your application to run because you are just simply asking the host to give you that amount of resources to run that application. It's like running a process directly on the host. So that's what a container is in the end. It's just another process running on your system. And that's why there is this maximization of hardware utilization. Then isolation and security, they go hand to hand. And very similar to VMs, although not as strong, containers also achieve some level of isolation through namespaces. And because you are isolating the execution of your application inside this bubble, you are also reducing the attack surface of your system, which is something that you desire. So that's one of the key aspects of containers as well. Then you will have a rich container management ecosystem nowadays because containers are popular. You'll find a variety of tools to help you build container images, things like Rawcraft, Docker, and so on. And on the other hand, for deploying containers, you also have a variety of tools. You have container managers, container tools, again, like Docker, and also container orchestration engines like Kubernetes to help you automate the orchestration of your applications in a sort of distributed environment. Finally, containers are best suited for agile and modular environments. So if you are trying to figure out how containers fit your software architecture, containers are A very good fit for something like CI/CD pipelines, a microservice architecture. If you need accelerated development and deployment, then containers are probably the best solution for such cases. And just to give you some additional information that is available from this Gartner report that you can find a reference to here at the bottom. There are many numbers in this report and estimations that point to the fact that containerization is growing. It's not just a buzzword, it's not just hype. And one of the most impressive numbers is to say that in just a few years from now, it is estimated that the majority of global organizations, more than 95%, will be running some sort of containerized applications in production. And this is the key word, in production. So there's a lot of container adoption going on. It's not just hype, it's here to stay. And this makes containers a very viable approach for production deployments. So when you start entering the discussions of containers, you will get to a point where, okay, there's certain terminology around containers that it's important to know. There's a container, obviously, but there's also a container image. There's a container registry. So how do you make sense of all of it? Before we talk containers, we should talk container images. A container image is the actual portable software unit. It is the artifact where you package the application and the dependencies. And this is an immutable blueprint for a container, right? It's a set of layers. The software that you are packaging inside this unit is packaged in the form of layers. It is read-only, right? And this is the blueprint from where you will start a container, right? And tools like Rawcraft and Docker, those tools will help you through recipes to build such an artifact. So you can write either imperative or declarative recipes, depending on the tool that you are using, to help you build this set of layers that are, again, immutable, but that you can use at runtime to tell, okay, I want to start a new container from that image. And this is what a container is. When you start a container, you are starting an instance of an image, right? You are telling your container manager, something like Docker or Kubernetes, you are telling it that, hey, here's this image, which, by the way, it's immutable. So I cannot just go there and start touching things. What it will do is create another layer, a writable layer on top of all the read-only layers that you have inside your image. And this is where your application will run. So it is in that layer that if your application needs to write something, it will be written there. If it needs to read something, it will just go to the read-only layers and read. If it needs to change something on those read-only layers, typically what it would do is to copy that content that needs to be modified, bring it to the writable layer and change it there. So that's one example of how things would work in a container, but the bottom line is that container is an instance of container image. And finally, there is the registry here. Now, as the name says, the registry is simply a sort of centralized store to enable the distribution of container images. In your software stack, you may have many different components. If you are dealing with microservice architectures, you may have tens, dozens, or even hundreds of different applications running side by side. So you will want to share that for other users to be able to use. So a centralized store is the registry. It's just a way for you to push as a developer your container images, manage those, give them names, version them, etc., such that other users on the other side of the world, anywhere, can just pull the same artifacts that you have built. And that's what a container registry is. And one popular example is something like Docker Hub. And that's pretty much it. That's the one-on-one of what are containers. If you want to learn more about them, you can follow this link here and read a bit more about what containers are, how we use them at Canonical. And that's pretty much it for this session.